Okay, if you are in Math 8, we are working from the Course 3 textbook. If you are in 7 Accelerated, we are working from the Advanced 2 textbook. We are doing Lesson 1.3, Example 1, and we are on page 20. Okay, so today we're going to be working on solving equations when we have a variable on both sides. What does that mean? Well, in this equation, I know I need to solve for a variable. I need to solve for x, but I have an x on the left and an x on the right. So what am I going to do with that? Well, which one do I solve for? Well, we're going to combine like terms. So here's my term with a variable, and here's my term with a variable. Since my constant is on the left, I want to move this variable to the right. I want to get it over here. And you guys already know how to do this. We're going to use inverse operations to get rid of the variable on one side and move it to the other. So I want to get rid of or undo this negative 2x on the left. So to undo negative 2x, I'm going to use the inverse operation and add 2x. What I do to one side, I must do to the other. So these guys cancel each other, and I'm left with 15 equals. I have negative 7x, positive 2x. Remember, negative ninjas and positive pirates go to battle and take each other out. So I'm going to subtract, and then I'm going to keep the sign of my largest number, because negative two positive pirates will take out 2 negative ninjas, and it will be 5 negative ninjas that are left standing. Okay, now this should look like a problem you already know how to do. We need to isolate that variable. So we need to undo this times negative 5. So to undo times negative 5, we're going to divide by negative 5. What I do to one side, I must do to the other. So 15 divided by negative 5, I have a positive and a negative, so my answer is going to be negative. Negative 5 divided by negative 5 is 1, so they effectively cancel each other, and I'm left with x. So x is equal to negative 3. Okay, let's do another one. Negative 3x equals 2x plus 19. So here again, I know I need to isolate my variable, but I have a variable on the left, I have a variable on the right. How do I isolate this? Well, we combine like terms. And since my constant is on the right, I think it would be easiest to move my variable to the left. So to get rid of or undo this positive 2x, I'm going to subtract 2x. And what I do to one side, I must do to the other. So negative 3x and negative 2x is negative 5x equals, these guys cancel, 19. Now, this is a problem you already know how to do. I need to isolate that variable. So I need to get rid of this times negative 5. Well, to undo times negative 5, I'm going to divide by negative 5. Okay, what I do to one side, I must do to the other. So -5 divided by -5 is 1. They effectively cancel each other, and I'm left with x. Now my answer here, I can leave it as -19/5, or it can be -3 4/5. I can convert it to a mixed number. Or it can be -3 8/10. I can convert it to a decimal. All three of these are equivalent values. All three of these are equal. They are the same. They just look different. That's all. So let's do another one. Okay. 2.5y plus 6 equals 4 5/10 y minus 1. So here again, I know I need to isolate my variable, but I have a variable on the left and a variable on the right. Which one am I going to isolate? Well, before we get started, let's combine like terms. And in this case, I want to keep my variable positive. So I think it would be easiest to move my variable from the left to the right. So to get rid of or undo positive 2 5/10 y, I'm going to use the inverse. So I'm going to subtract 2 5/10 y. What I do to one side, I must do to the other. So these guys cancel, and I'm left with 6 equals positive 4 5/10 y minus 2 5/10 y is positive 2y minus 1. Now this should look like a problem you already know how to do. I need to isolate my variable, but first I need to undo or get rid of this -1. So to get rid of -1, I'm going to undo it with +1. What I do to one side, I must do to the other. So 6 plus 1 is 7. And I'm left with 2y. They cancel. Now, this is definitely a problem you know how to do. I need to isolate my variable. So I need to undo or get rid of this times 2. To get rid of times 2, I need to divide by 2. What I do to one side, I must do to the other. Okay, so y equals, these guys cancel. I can leave my answer as 7/2, or I can turn it into a mixed number, or I can turn it into a decimal. All three of these are the same value. They just look different. All three of these would be acceptable. Okay, I'm going to give you one, and I want you to try this on your own. The only way to truly know if you understand how to do it is to try it. So r equals -5r plus 18. So I want you to try this on your own. Okay, a lot of answers are coming in and things are looking pretty good. Let's solve this one together. So I have a variable on the left, and I've got a variable on the right. I need to combine my variables, and in this case, I think it would be easiest to move the one from the right to the left. So I want to get rid of this -5r. So to get rid of it, I need to use inverse operations. I'm going to add 5r. What I do to one side, I must do to the other. Now this is 1r. We don't write 1. The 1 is implied. So this is 1r. That 1 is implied. So 1R plus 5R is 6R. These guys cancel, and my 18 comes down. Now this is a problem you know how to do. I want to get rid of or undo this times 6. So to undo times 6, I need to divide by 6. What I do to one side, I must do to the other. R equals 18 divided by 6 is 3. Okay, there's one problem I want to set up with you before you get started on your homework. Okay, part of your homework is the car problem. Write and solve an equation to find the number of miles you must drive to have the same cost for each of the car rentals. So we want the green rental to equal the blue rental. We want to know how many miles before the green rental is equal to the cost of the blue rental. Well, the green rental is $15 plus 50 cents per mile. And we want to know how many miles until this equals the blue. And the blue is $25 plus 25 cents per mile. So here it's less money up front, but more money per mile. The blue car is more money up front, but less money per mile. So we want to know at how many miles is the rental the same. This is good information because then you can decide if you're going on a trip. If you're going to be going on more miles, you probably want to rent the blue car. But if you're going to be traveling less miles, you might want to rent the green car. So that's how this applies. Okay? So remember, a word problem dictates a word answer. When you get M equals, that is M equals the number of miles you must drive to have the same cost for each of the car rentals. Okay? So I'm not going to solve that for you, but I did want to help you set that up.